Hello guys, so today we are going to see a very important problem generally asked in interview rounds. So whatever the problem is, like first, the very important thing is you don't get started right into coding after you see the problem. So the first thing is like whenever you get a question from the recruiter, it is generally on a doc sheet or some sheet and you read the problem from there and the interviewer will ask you to like solve the problem on the same sheet, right? So generally many candidates what they do is they jump right into the code and start coding the solution. That is the very wrong approach. So today I'll help you out with the things that you can do with the recruiter so that uh, it is the best of you. So the problem is given an array of integer numbers where array of I is the number of pages, right? So there are m students and we need to allocate all the books to the students. But we have three conditions. Each student gets at least a book. Each book should be allocated to one student and it should be in a contiguous manner, right? So you have to allocate the books to a student such that the maximum number of pages assigned to the student is minimum. So, like before you jump right into the thought process or solving the question, ask the interviewer like what are the cases? Like what can the number of pages be? Can it be negative numbers? Uh, you you won't ask it would be a negative number because you take it by default that it is always positive, but the interviewer may assign those numbers as negative. So it is always helpful to ask such clarifying questions in the interview. That shows that the candidate is not oriented to the solution but the problem. So uh, okay, so after that, uh, I'll try to explain how to push your thought process to the interview. So let's say we have this array A1, A2, A3, A4, A5, and so on. Right. So the first condition says that each students get at least one book. So let's say students S1, S2 up to there are n students, right? Number of books are n, number of students are m. Okay. So and each book should be allocated to only one student. Okay. And the book allocation should be in a contiguous manner. That means you cannot allocate this book and directly this book to a student. It should be in a contiguous manner. Means if you allocate A1 and if you want to allocate A3, then A2 should be also allocated. So we can divide this array into sub-arrays, contiguous sub-arrays, right? Okay. So even if we have solved this problem, the most important thing is we always dive into the optimal solution of the problem, but the recruiter doesn't want it. He wants your thought process, like how you get to the solution. So uh, this is the case. So how can we solve this? We want to allocate this continuous part in to the students, and we have m number of students, right? And we want the maximum number of pages assigned to the student is minimum. So first of all, let's see the limits that what will be the limit of the pages assigned to a single student. Let's say some student S, what will be the max and what will be the minimum. The approach that I'm telling is gonna help you, like not only for this problem, but any problem you encounter. So let's get the limits. So we want the maximum number of pages assigned to a student is minimum. So if we assign each book to a student, then what will we have? We'll have the minimum value, right? But the maximum number of pages assigned to a student is minimum. That means uh, how many pages can we allocate to a single student? Like if we allocate each book to a student, what will be the minimum value? The minimum value will be the maximum value, right? Because we want because if we allocate some x, y, z to students, the answer for this case will be the maximum value among x, y, and z. So the minimum value will be the maximum value of the array, the maximum number of pages for any book in the given array, maximum of array. And what if we give all the books to a single student? So that will be the sum of all the AIs. That can also be a case. Let's say we have one student, right? For one student, we need to allocate all these books to that person. So it will be the sum of all the pages. So now we got the minimum and maximum value for the student, right? Now we know that the maximum value is, hmm, sorry, the minimum value is like the range is max of AI, comma sum of AI, right? This is our range in which we want to allocate all the books. So what we can do is like we can pick any range, any number in this range, let's say X, and we'll see how many students can we like how many students can get number of pages less than or equal to X, right? So how can we find this? We define a function f where we take in this value x, and it will return the integer that will determine the number of students that will be able to get number of pages x or less than x, right? So what we'll do, but the condition that this problem has, that book allocation should be in a contiguous manner, right? So whatever our array is, A, B, C, D, so it should be a contiguous manner like this one, as an example. So what we'll do is we'll limit the number of pages assigned to a single person as X. This is our X. So let's say the number of students is S. No books have been allocated to any student. So now we'll iterate over the EIs. Now we'll see that, and also we need to consider the number of pages that the current student has. So initially our current is 0, right? We have no pages assigned, we have no students like completed anything. So the current is 0. So now what we'll do is we'll check. We want to check a limit on X that each student should have at max X. So we'll check that if we want to assign this book, like if we want to assign any book, say A, B, C, D. So if A is uh, more than enough, then we will limit this subarray here and we'll start a new array here and we'll extend it until it satisfies this condition, right? So if we'll see if current plus AI is less than or equal to x, then we will increase the current, right? Because we want the current student to get those books. But in the else condition, we'll need to break this loop, right? So the new student should get it. So in that case, we will increase the number of student and we will assign current to the current value. And at last, we return the number of students uh, that successfully got uh, books which has an limit on x. So this is the function that is gonna help us throughout the process. Like if we have any value x, we say, and it will tell whether all the students got their books or not. Okay, so as we knew that the limit for the values of x, that x belongs to maximum of ai, comma, summation of ai, right? This is the limit. So the first approach, generally many candidates, what they do is they don't go over the brute force approach or whatever the first approach that comes to their mind, but they just directly go into the solution which they learned or whatever. But going directly into the optimal solution is never an answer. They want to see your thought process, not the number of problems you solved and the number of approaches you know. So this is the limit, right? So what we can do is, in the simple case, the first case, what we can do is we just iterate over all these x values. Let's say x is equals to max of ai and x less than or equal to summation of ai, x plus plus, and we'll check. Let's say int students satisfied. So satisfied is equals to, we'll call this function f of x, right? So if we get that the number of students is satisfied is m, because the question says we should allocate all the students at least a book. So the solution that this should give should be m, and among all the values of x, we'll find the max, like the minimum value. So we'll try to find the minimum value, and if we find that, we break, right? So this is the brute force approach, and what time complexity is gonna be is, like, we are iterating through the values ai, summation of ai, maximum of ai, and for each step we are uh, going through this array, right? So the time complexity is going to be this. Can we further reduce it? Can we directly find the value of x that is going to satisfy this condition, and we can use a similar sort of function f to determine whether it is good enough or not. So if you have done any competitive programming or have practiced DSA, you may have known that we are going towards binary search, because if we are searching any value in a given range and it satisfies some sort of it has some sort of constraints or properties. So in that case, we use binary search. So what we are gonna do is, like, we as we know the limits of x, that is max of ai, comma, summation of ai. We'll just binary search the value x that is gonna be satisfied, and we get our answer. So in the optimal case, you should write a pseudocode. First, you should discuss this brute force approach to the interviewer. Then, how you found out about the binary search, because you can explain that for this case, the limits were set. It has specific property for all the elements. So you can use binary search to reduce the searching length. So this is what the interviewer will accept and not directly going into brute force. So now you know that you can binary search in this region in the same interval. How are going the low and high be affected with those? Let's say we call if you know the binary search, we generate the mid and we check some properties on mid. So in this case, X is the mid. So now, if the number of students we get is less than m, right? So if less than m number of students are going to get satisfied, then what should we do? Which should we increase the low or should we decrease the low? Okay, you may have guessed it that if the number of students satisfied the m, we should decrease the searching range. Like if this is the range, we should cut it here and so that maximum number of students get. So basically we are decreasing this one. So that means we should assign this mid minus one. Before all of this, as I assume that you guys must know the binary search, I'm directly jumping into it. Otherwise, you should uh, tell the interviewer about the binary search, like how it works and how the ranges get split, and we just get to the optimal solution. I'm directly jumping into the binary search values, so that's on your part. And if it is greater than or equal to n, so we can in, uh, increase the mid. Like, okay, so after all of this, what we need is the such that the maximum number of pages assigned to the student is minimum. So basically, we want to return the low because this will anyway run on this condition, right? So we just return the low. So this is how the solution works. But if you just get to it and you think this is the end, the interview will reject you because you just missed a condition that if the book allocation of books is not possible, return minus one. When is this case? Think of it. Okay, you may have think that if if the number of students is greater than the number of books, like the size of A array, so in this case, we won't be able to satisfy all of the students because each student needs to get at least one book. So in this case, we can return minus one. On the After you gone through your solution, your approach and everything, then you jump into the code editor and you can start writing the code in a well structured manner. Like how can we show that the any test case that the user like the interviewer have may given, you can write it here. And now we for any type of function we try to have helper functions for each of them. Let's say now we are calling find pages, right? Because we want to find the number of optimal pages. So we define a function find pages. We take the required parameters and First of all, we write the base case that when it is not possible to allocate any books, we write that if the number of students is greater than the number of books, so in that case we won't be able to allocate. Now we get to the low, the high of the binary search as we discussed, the ranges for the value of x. So we write a basic binary search code and return it. And here, as you can see, is this is a helper function to calculate how many students got satisfied. This is the same thing, and yeah, this is how you can approach any question on particular part of problem solving and DSA. And this question was asked in Google, Flipkart, and Nutanix. Not because this question is difficult, but they want to know your approach, how you tackle the problems, and that's it. In the upcoming videos, I'm going to share some wonderful resources that gonna help you with code forces or let's say code safe, top coder, or any competitive programming problems that you are gonna solve. Also, they help in the problem solving ability so that even if there is a difficult question in the interview, you can go through it. Yeah, that's it from my side. Thank you for watching.